and welcome to today's webinar. We're going to be going through a webinar that features the integration between our new SeisVision 64 Geophysics environment and our Smart Section Geomodeling environment. We'll be integrating both of these things to highlight the new capabilities within GeoGraphix, including fast seismic interpretation, both in 2D and 3D auto picking. I'll also introduce the new depth conversion and our velocity manager in the new SeisVision 64. And in it, I will integrate the seismic interpretation for optimal geomodeling. Following that, we'll wrap up with some housekeeping that Justine will take us through and then take questions. GeoGraphix 2014 offers to build upon the leading capabilities of GeoGraphix you know in the past, including a lightweight, easy-to-use capabilities. As a matter of fact, I'm using my laptop today. And we optimize key workflows, particularly in the unconventional areas, and improving our content to try to streamline those workflows. We've moved into engineering areas to integrate geology, geophysics, and engineering, particularly in our new advanced field planning tool that Scott Elfcombe, my colleague in product management, will take you through in a webinar later this month. We also have these improved capabilities at an unparalleled price point within our market today. We build upon our core competencies in geology and geophysics by adding field planning. Field planning is going to be a licensed tool released with the 2014 release that will allow you to plan multiple wells well ahead of time along a target surface, so you can stay well ahead of the borehole and maximize your rig time. We also have a new tool to maximize our 3D visualization called Reveal. Reveal will allow you to actually graphically select an area of interest on your map and then reveal those 3D objects such as wells, cross-sections, surfaces, seismic lines in a new 3D environment. Scott will also be demonstrating that in his webinar later this month. Now, LMKR has a new volume attribute tool that I want to make sure everybody understands, even though I will not be presenting it in this webinar. It will be presented in the one that Scott will be doing. This is a new product that does 3D attributes, including both trace-based and frequency-based attributes, spectral deconvolution to optimize the creation of semblance and ESP volumes. In addition, we have a new LMKR well planning tool. This tool will allow you to do single or multiple well plans based upon either a 3D surface or a smart section and cross section. This will also be demonstrated in Scott's webinar later this month. So with that aside, we'll go ahead and start the demonstration. Our workflow will be to examine the teapot dome structure, cross-section, seismic backdrop in Smart Section, our 3D visualization and geomodeling environment. Then we will interpret the tin sleep C1 dolomite horizon in new SeisVision 64. I will create and apply a new velocity model, and then use that velocity model to convert the horizons and faults to depth in SeisVision, and use those 3D depth-converted surfaces to control the Dakota and C1 surfaces in the geomodel, and also use them as sources for data for the A, B, and C faults in the geomodel. This will improve the geomodeling in the cross-section and also correct the seismic backdrop view. So with that aside, let's turn our attention to the demonstration. On our screen, you will see Project Explorer with the project activated. And I'm going to be starting the workflow through Smart Section over here on the right, the little square cube. This is our geomodeling environment for those who may not be familiar with Smart Section. When you first launch Smart Section, the first thing you see is a map. And on this map, I've got currently being modeled the C1 dolomite within the tin sleep formation in the teapot dome area. This is the producing zone. This surface is being modeled on the fly using triangulation and minimum curvature smoothing using these data points indicating by these purple well symbols. Now this is a 3D environment, and as I move to other zones like the Dakota here, you see this is being modeled over a larger area because it's a shallower zone and therefore has greater sampling. Behind Smart Section, I've got a 3D topology engine of which I've loaded 3 surfaces. The B1 zone, the shallowest, the Dakota, and the C1 dolomite. And I've set up a hierarchy of surface constraints. Since the Dakota is shallower and better modeled, as I showed you on the map, it's going to control the conformance of the C1 dolomite when I apply the conformance. So let's go ahead and look at this cross section from west to east, indicated here by the line of section. So this is the surface, the B1 surface, the Dakota surface, and the C1 dolomite surface. And you can see the shallower surfaces are actually sampled by more wells than the Dakota. But by applying the conformance tool here, you'll see it will apply the Dakota conformance down upon the C1 dolomite. And you can see it fleshes out the C1 structure in a much larger area. Now I also have a seismic interpretation with a velocity model that I can use to display a depth-converted seismic backdrop on the cross-section. Now this is actual seismic data that's being processed on the fly, depth-converted and scaled to the cross-section. I think you'll first notice that some of the events do not correspond or do not line up with their corresponding geological picks. This is the B1 surface, that's the B1 event. The Dakota is not too bad, but the C1 is departing from its C1 event, and also there's some warping in this area. This is due to naively or incorrectly modeled velocity over in SeisVision. So let's shift over to SeisVision. This is our new SeisVision 64-bit coming out with a 2014 release. And we've optimized another number of areas in here. One area is well loading. Well loading is now an order of magnitude at least faster. Our 2D picking, auto picking, is much improved, and our 3D auto picking uses the same parameters, so it's also much improved. We've also added this pick parameters panel over here, which will allow you to interface with whatever event you're going to be picking and adjust its picking parameters as you need to without having to go into the Horizon Manager. Now this cross-section right here is our east-west section. Now I'm going to be using the, let's go ahead and get the pick set up here, strongest, and I want to do 2D auto picking. So based upon my synthetic seismogram I've got here that I created over here in Log M, I can see the B1 event is this trough indicated by the synthetic against the seismic. The Dakota is the strong positive event here, and the C1 dolomite down here is a strong positive event. So I'm going to be picking the C1 dolomite in the Tinsley and also on the north-south cross line here. There. Now you'll also notice that this B1 surface up here has already been picked, but it doesn't very well correspond with the time conversion of the B1 pick from well base. The Dakota's not too bad, but if I look down here at the C1 dolomite, again the C1 dolomite event does not correspond well with the time converted C1 formation picks here. That's because I have a poorly modeled velocity model. So I'm going to use the new depth conversion tool to correspond my Tinsley time horizon to the C1 dolomite formation in well base, the Dakota time horizon to the Dakota formation, and the shallow marker to the B1. Now this is going to create a 3D velocity model applied over the area with an improved algorithm over the traditional velocity modeling that you may have been used to in SeisVision. So with that velocity model built, I'll apply it through our new Velocity Manager. And click OK. And you'll see now that the C1 dolomite fits exactly against the C1 event. The Dakota is spot on, as in the B1 event in its formations. Now if that's created, let's go ahead and do a 3D auto pick. over this area. Convert it to depth using the new velocity model. Now this depth converted surface is now available to us as a source of data for our 3D model in Size Vision, in Smart Section, I should say. Likewise, I have three faults: the A fault, the B fault. The B fault is this fault here, you can see on the inline 146, and the C fault, which can also be directly depth converted using our updated velocity model. And so let's go ahead and return over here to Smart Section. And let's go ahead and put in as a source for the Dakota horizon. And then for the C1 dolomite, we are going to add, in addition to the well picks, we're going to add those depth converted surfaces as sources for these surfaces in our geomodel. In addition, we're going to add for the ACE fault, the A depth converted fault from Size Vision as a source, and combine that with the B pick here that's actually in the fault manager. Click OK, apply that, and apply the updated velocity model overall. Go ahead and process on through. And you'll see now we have a much higher frequency and much better modeled surface here. I'm going to go ahead and turn on the intersection of the A fault with the C1 dolomite. And the C fault as it intersects the C1 dolomite. And zoom into our area so you can see the effect of the cross-bending faults and the fault polygon being generated against the C1 surface right here. And apply the fault offset so you can see the actual fault polygons being generated. There they are. Now these are the fault polygons. You can see the offset in the contours against the faults. And return here, turn off the seismic backdrop and refresh it with the new velocity model. And you can see now the events that are depth converted from Size Vision are lying directly over the geomodel surfaces due to the improved velocity model and the insertion of the depth converted surfaces into the geomodel here. So let's wrap up. What have we done? We've integrated both domains of geology and geophysics together because there really are a 3D view of the world. The geophysical view is a time view, the geological geomodeling view is a depth view, and they're integrated through a much improved velocity model in Size Vision 64. I introduced the new depth conversion and velocity manager modeling tool and combined those interpretations to give us the best geomodeling results possible. So why GeoGraphix? We believe we have the most comprehensive and highly integrated geoscience interpretation system on the market today.